Hello and welcome to the last part of our alien shooter game tutorial. Last time we finished up by drawing the enemy. Today we will continue with the update player function. First we check if the left arrow key is being pressed and make sure the player hasn't reached the edge of the screen. If both conditions are true, we move the player to the left by subtracting from their X position using their speed. Then we do the same for the right arrow key, but this time we make sure the player doesn't go off the right edge. If it's safe, we move the player to the right by increasing the X position. When the player presses the spacebar, we first check if enough time has passed since the last shot. This is controlled by the player fire rate, which sets a limit so the player can't spam bullets too fast. If the timing is right, we create a new bullet. It spawns at the center of the ship and moves upward on the screen. Next up is the update bullets function, which keeps all bullets moving. Every frame, we loop through each bullet and update its position based on its speed. Player bullets move upward and enemy bullets move downward. The direction depends on whether the bullet is friendly or hostile. We also check if a bullet has gone off the screen. If it has, we remove it from the array to keep things clean and efficient. This helps the game run smoothly by not keeping bullets that are no longer visible. Let's take a look at how enemy movement and attacks are handled in our game. The update enemies function is called on every frame, and it updates the behavior of each enemy on screen. We start with a for each loop that goes through every enemy in the enemy's array. Inside the loop, the first thing we do is move the enemy downward. We do this by increasing the enemy's Y position by their speed, divided by 4. This gives us a smooth, slow descent for the enemies. Next, we check if the enemy should fire a bullet. We use math random to generate a number between 0 and 1. If that number is smaller than the enemy fire rate, the enemy fires. A new bullet is created using the create bullet function. It spawns from the center of the enemy, and it's marked as an enemy bullet by passing false as the third argument. This bullet is then added to the global bullets array and will be updated and drawn in other parts of the code. Finally, we check if the enemy has reached the bottom of the screen. If the enemy's position plus its height is greater than or equal to the canvas height, the game ends. This simulates the enemies invading and reaching the player's base. So in short, this function makes enemies move down, sometimes shoot, and triggers a game over if they get too far. Now let's walk through how the game detects when bullets hit enemies, or the player. The check bullet collisions function handles all collision logic between bullets and other game objects. We start with a loop that goes backwards through the bullets array. Looping backwards is important because we might remove bullets from the array as we go, and we don't want that to mess up the loop. Inside the loop, we grab the current bullet, then we check if this bullet was fired by the player. If it was, we check if it hits any enemy. So we run a nested loop, again going backwards through the list of enemies. We call the check collision function, which returns true if the bullet overlaps with an enemy. If a collision is found, we remove the bullet from the bullets array using splice. Now here's a cool part. If the enemy is of type tough, instead of destroying it, we downgrade it to a basic enemy. We do this by replacing it with a new basic enemy at the same position. Otherwise, if it's not a tough enemy, we remove it entirely from the game. And then we update the score. Fast enemies give 20 points, while others give 10. We also update the score display on the screen. And finally, we break out of the enemy loop, since a bullet can only hit one enemy. Now, if the bullet wasn't from the player, in other words, it's an enemy bullet, we check if it hits the player. If it does, we call endgame, and the player loses. So to summarize, this function handles all bullet collisions. It removes bullets and enemies as needed, updates the score, and triggers game over if the player gets hit. Let's take a closer look at how the game listens to player input, and how the main game loop keeps everything running in sync. We start by declaring an empty object called keys. This object acts as a real-time tracker for which keys the player is pressing. To make it work, we add 2 event listeners to the document. One listens for when a key is pressed down and sets the corresponding key code in the keys object to true. The other listens for when that key is released and sets it back to false. This way, we always know exactly which keys are currently being held, like the left and right arrows for movement or the space bar to shoot. Now let's move on to the heartbeat of the entire game, the game loop function. It starts by checking if the game is currently running. If not, it simply exits and does nothing. Next, we clear the canvas using CTX clearrect, which removes everything from the previous frame. This gives us a clean slate to draw the next frame. Then we update all the key components of the game. We update the player's movement, move all the bullets, shift the enemies, and check for any collisions, like bullets hitting enemies or enemies reaching the player. After the logic updates, it's time to draw everything on screen. We draw the player, each bullet, and all the active enemies. Then we check, have all the enemies been destroyed? If yes, we level up. The wave counter goes up, the display updates, and we spawn a new wave of enemies. Finally, the magic behind smooth animation, we call request animation frame, which loops the game loop, function again and again, creating a continuous, smooth animation that makes the game feel alive. And that's how we keep the game running, updating, drawing, and responding to player input in real time. Now let's walk through how the game starts and ends. First up, the start game function. This function kicks things off when the player begins or restarts the game. Right at the top, we check if the game is already running. If it is, we simply return. We don't want to restart everything if the game is already in progress. Next, we initialize the game's core state. We create a brand new player, clear out any old bullets and enemies, and reset the score and wave number back to their starting values. Then we update the on-screen score and wave display so the UI reflects those new values. We also set game running to true, signaling that the game is now active. Visually, we hide the game over overlay in the instructions box, clearing the screen so the player can focus. Now that everything is reset, we call spawn enemies to create the first wave of enemies. And finally, we launch the main loop by calling game loop, officially starting the game. Now let's look at how the game ends. The endgame function stops everything when the player loses. We first set game running to false, which halts the game loop. Then we cancel the animation frame using cancel animation frame. This freezes the action and prevents any more updates or rendering. Next, we update the final score display with the player's last score. And to bring everything to a close, we show the game over overlay, letting the player know the session has ended and prompting them to restart. Now let's talk about how the game handles restarts and difficulty levels. First, the restart button. When the player clicks the restart button, the start game function is called. This resets all game elements, like the player, enemies, bullets, score, and wave number, and starts the game loop again. Now, on to the difficulty selection system. Each difficulty option, easy, medium, and hard, is tied to a button in the interface. When a player clicks one of these buttons, the game reads the difficulty level from that button and stores it in a variable called difficulty. Next, the visual feedback. The clicked button is highlighted by adding an active class to it, while removing that class from the others. Then, depending on the chosen difficulty, the game updates 3 key settings: enemy speed, how often enemies shoot, and how quickly the player can fire bullets. Here's how each mode works. In easy mode, enemies move slower, fire less frequently, and the player has a slightly longer delay between shots. In medium mode, the pace is balanced. This is the default setting. And in hard mode, everything is faster. Enemies move quickly, shoot more often, and the player must react rapidly. This system gives the player control over how intense they want the game to be. Now let's break down the final part of our setup. The first line automatically highlights the selected difficulty button when the page loads. It does this by finding the button that matches the current difficulty, using the data difficulty attribute, and adding the active class to it. This ensures that the user sees which difficulty is selected right from the start. Next, we handle the instructions close button. When the player clicks the close instructions button, the game hides the instructions box. And if the game isn't already running, it immediately starts the game. This provides a smooth transition from reading the instructions to jumping straight into gameplay. Now I will go over some mistakes that I did along the way. First, I will fix the type with the Close Instructions button and Instructions box. Then I will fix the typo in the X width for the player, and I will add the missing height. Fix the Close Insertions typo in the Get Element BID for the Close Instructions button, and lastly, fix the game running status when we click the Close Instructions button to be reversed. With this, you should now have a fully working alien shooter game with different difficulty modes. I hope you liked this tutorial. If you did and would like to see more videos like this, please don't forget to like and subscribe. All the source code will be linked in the description. Thank you all for watching, and as always, stay frosty, and I will see you in the next one.